Now that you have your data, we're going to graph it. So you're going to need to open Logger Pro. Once you have it open, you're going to go to the X column under the data set, double click, and we're going to name our columns. One column will be position, one column will be time. Short name for position is X. Units are going to be in meters, please. Your other data column, Y, is going to be time. Short name for time is T. Units for time is seconds. Then you'll enter your data, positions and times, and then we'll go to graphing it. So pause the tape, enter your data, and then we'll come back once your data is in and we'll take a look at what to do with it next. So here we have our position and time data. Double clicking on the graph will get us to graph options, axis options. Within graph options, remember here is where you put your title in. You want to make sure point protectors are checked. You want to make sure connect points is unchecked. Then you're going to go to axis options. We want position on the vertical axis, so here's the y-axis. We want to check position. At the bottom is time. We want to make sure time is on our x-axis, and then we'll tell it done. We want to look at data. You want to make sure that your scale is such that the page is filled with your data points, not having lots of empty white space. What you want to do next is go up to Analyze in the menu bar. If you click on it, you're going to come down to Curve Fit. Click on Curve Fit, and if we start at the top and work our way down, we'll figure out what the best fit for our line is. We normally do a straight line, which is mx plus b, y equals mx plus b. It's clearly not linear, so we're going to try the next one down. This is a quadratic equation, so let's click on that. Then you come down to the middle, bottom, where it says Try Fit, and click on that. That looks pretty good. So we will say that works, and we'll tell it OK. When you're entering your data in your data table, please make sure that you have 0 position and 0 time as 2 of your data points. Now I have data points, I have a curve fit line, and I can see what my position time graph looks like. Since it's not a straight line, what that tells us is the velocity for our object is not constant. It's changing because we have a curve instead of a straight line. We want to generate a new graph, and we learned in our last unit that when we have a position time graph, the slope of the line is velocity. Well, velocity keeps changing, but we can figure out what it is, and what we can then do is generate a velocity time graph. First thing we need to do is go up to Data, come down to New Manual Column, and we're going to label this column Velocity because we want to find the slope of our line at a variety of time points. So there's our velocity column. The units are meters per second. Now what we're going to do is we're going to go up to Analyze in the menu bar, and we're going to come down and click 2 things. We're going to click Tangent, and we're going to do it again, and we're going to click Interpolate. What we want to do is find out what is the slope of the line in the time intervals that we measured. So we do that by just moving our cursor along the curve. Up in this box here, we have times and we have positions, and what we want to do is try and get our time as close to the times we measured and find out what the slope of the line is, because that will be our velocity. So we're going to start out with our first non-zero time, so that's 0.35. So we're going to move our cursor along the line until we get as close to 0.350 as we can. It's a little bit of Zen, and it's a little difficult to get the cursor just to the right place. So that's pretty close. So 0.35 seconds for our data set. Time on the graph, 0.3507, works for us. So we take note of the slope of the line at this point. It's 0.4224. We're going to take 3 places to the right of the decimal. So in our velocity column, remember the slope of this line is the velocity of the object. We're going to type in the slope. So we have 0.422. Ideally, you're going to do every point along here. So if we go to the next one, we want to find our time at 0.687 seconds. So we keep moving our cursor until we get close to that. So 0.689 is pretty close to 0.687, so we're going to use that one. The slope of our line at this point is 0.8545, so we'll call it 0.855. You'll generate velocity for all of your times except for the 00 time. To save time, I'm just going to do these. Once you have that, you're going to create a new graph. So you're going to Insert, a graph, and so we're going to make it bigger so we can see what's going on. You will need to title this one as well. That's under graph options, putting in the title. So we'll title this velocity versus time of our object. Those data points look pretty straight, so we're going to do a best fit line. Remember, that's in the menu bar, the R equals, so there is our line. Ideally, you want these values here to be 0. So now I have my line approximating 0, 0. So I have a velocity time graph, I have a position time graph. The last graph we're going to make is a graph similar to the ones that we worked with in our first unit. We have a curved line. We learned how to linearize graphs when we have a curve. So this type of graph, we have a top opening parabola. So do you remember what you need to do to get it linear? Hopefully you remember that what you need to do is square the values in the horizontal axis. So that's time, so we need to square time values. The way we're going to do that is we're going to come back and activate our data table. We are going to go to data and we're going to do a new calculated column, because we don't want to type more numbers in. So this calculated column is going to be t squared, time squared. Remember, you can go to the right. Remember, there are superscripts over here, so we want to square time. So there's time squared. Short name, we'll just do t squared. And our units are going to be seconds squared. In the equation box, we're going to choose the variable that we want to square. That would be time. And then we're going to apply the function we want to get what we need. So our variable is time, and we want to square it. So we don't have that little squared feature here, but we can do Shift 6 or caret and then 2, and that's squaring our times. Once we click in the done column, now we have a column of time squared. We have a column for velocity, we have a column for time, and a column for position. Now I'm going to insert one more graph. So if we title this, it will be position and time squared that we're going to have on this graph. So on the vertical axis, we want position. On the horizontal axis, we want time squared. So there's our graph. Let's change our axis a little bit here. That looks pretty straight, as it should, because we've linearized it. That means we can go up to our R squared button, click on it, and now we have a linearized graph. So we have a position time graph, we have a position time squared graph, and we have a velocity time graph. Once you've created all of them, you want to make sure that you save it. Then what you want to do is copy and paste it into a Word document, because you want all 3 graphs in your lab notebook. So we'll just copy it and paste it. You will need to do that in the Open Office documents on your laptops. So now I have 3 graphs on one sheet of paper. Remember, they don't have to be that big. They can be about 1/3 of the size of the page. If you, when you are in picture mode, choose tight as your text wrapping, then you can move them wherever they fit on the page. I think you can do that with your OpenOffice program. Then you have all 3 graphs on one sheet of paper. You need to print it. Each person needs all 3 graphs. They need to go in your lab notebook, and they need to go in this order. Position time graph goes in first. Velocity time graph goes in second. And position time squared graph goes in third. And then what we will do tomorrow is we will talk about what these graphs mean, how they're related to each other, in the equations that they provide for us. So your goal for today is getting these 3 graphs done. And if you don't get them done in class today, then you need to make sure that you can come in and get them done so that they're ready to go for Friday.